Today we are going to discuss gas laws, but before it we are going to discuss some characteristics of gaseous state. Gaseous state is the simplest state of matter. Gases have much lower density as compared to the solid and liquids. Gases assume the shape and volume of the container. Gas molecules are always in motion. That's why they exert pressure equally in all directions by colliding to the walls of the container. Because gas molecules are always in motion, that's why they can mix evenly and completely in all proportions without being stirred. Force of attraction between gas molecules is minimum. That's why gases are highly compressible. To define the state of any gas, you have to define its temperature, pressure, volume, and number of moles. These are known as variables. These variables are related to each other. To find out the relation between any two variables, you have to keep rest of two variables constant, and the relation between two variables is given by the gas law. Let's try to find out the relation between volume and number of moles. How volume is related to number of moles? Here we have to find out the relation between volume and number of moles. The other two variables, that is pressure and temperature, we have to keep them constant. The relation between volume and number of moles given by Avogadro law, and this law was derived by Amedeo Avogadro. So let's see what is Avogadro law. Avogadro law gives the relation between volume and number of moles. There are two balloons, balloon A and balloon B. Both the balloons are filled with same gas under the same temperature and pressure condition. So what you have observed here? Volume of balloon A is bigger than the volume of balloon B. Balloon A contains more number of moles as compared to balloon B. So what relation can you establish between volume and number of moles? Greater the volume, greater will be the number of moles. That means volume is directly proportional to the number of moles at constant pressure and temperature. According to Avogadro law, equal volume of all gases under same temperature and pressure contains equal number of moles. That means if volume A is equal to volume B, in that case, the number of moles in A will be equal to the number of moles in B. Or you can write volume is directly proportional to the number of moles. When you remove this proportionality sign, you will get a constant. So you will get V is equal to K multiplied by M, where K is the Avogadro constant. Now come to the graphical representation of Avogadro law. If I plot volume on the y-axis and number of moles on the x-axis, here you will get a straight line that originates from 0. This straight line shows direct relationship between volume and number of moles. That means volume is directly proportional to the number of moles. We just have derived this equation. Volume is equal to Avogadro constant multiplied by number of moles. So when you transfer this number of moles on the other side of the equation, you will get volume divided by number of moles is equal to constant. If you increase the number of moles, its corresponding volume will also get increased. For example, there is N1 number of moles, and its corresponding volume you will get as V1. When you increase the number of moles to N2, corresponding volume will also get increased. And for 0 number of moles, S occupies 0 volume. So what is the application of this Avogadro law? You can find its application in the mole concept. 1 mole of each gas at constant temperature and standard pressure occupies the same volume. 1 mole of any gas occupies 22.414 liter volume. That means the equal volume of all gases under same temperature and pressure contains equal number of molecules. Now let's derive some formulas for Avogadro law. Here there is a balloon, and if some of air escapes out, its volume will reduce. So I can consider first balloon as initial state and the second balloon will be the final state of the balloon. At the initial state, volume will be V1 and number of moles can be considered as N1. And for the final state, volume can be considered as V2 and number of moles can be written as N2. Now let's apply the Avogadro law. According to law, we know volume is directly proportional to number of moles. And when you remove this proportionality sign, you will get a constant. So you will get volume is equal to constant multiplied by number of moles. When you transfer this number of moles on the opposite side of the equation, you will get volume divided by number of moles is equal to constant, that is. Now let's apply this formula for the initial state as well as for the final state. For initial state, you will get V1 divided by N1 is equal to constant. We can consider it as a equation 1. Now apply the same formula for the final state. The final state we will get V2 divided by N2 is equal to constant, and now write it as a equation 2. Now compare both the equations. Right side of both the equations are equal, so left side of both the equation also become equal. So you will get V1 upon N1 is equal to V2 upon N2. This is the formula that we are going to use to solve numerical problems based on Avogadro law. So let's solve one question based on it. 1 mole of helium gas fills up an empty balloon of volume 1.5 liter. What would be the volume of the balloon if an additional 2.5 moles of helium gas is added? Assume that temperature and pressure are kept constant. So this is the balloon that is initially filled with 1 mole of helium gas and its volume is given 1.5 liter. Now they have added additional 2.5 moles to the same balloon. That means number of moles of N2 will be equal to 1 plus 2.5 moles. And here we have to calculate volume of second balloon. So let's apply the formula. We have formula V1 upon N1 is equal to V2 upon N2. Now place the values in this formula. So we will get V1 is equal to 1.5 liter. So I have written here 1.5 liter divided by N1, that is 1 mole is given in the question, is equal to V2 that we have to calculate divided by 1 plus 2.5 is equal to 3.5 moles. Now solve this equation. So when you transfer 3.5 moles to the opposite side of the equation, you will get 1.5 liter multiplied by 3.5 moles divided by 1 mole. Mole will cancel out by mole and 1.5 will multiply by 3.5, and on solving it you will get 5.25 liter. And this is the answer for this question. In the next video we are going to discuss Boyle's law.